Hello, I'm Ron Covell. This is the fourth in a series of videotapes on metalworking. Today we're going to take a look at making gas tanks for motorcycles. The motorcycle we have here is owned by Darren Rock from San Francisco. Darren did the design of this motorcycle and I love the asymmetry of it. You can see that the gas tank sweeps off to the right and the seat will sweep off to the left to pass by it. For our video today we're going to tackle a simpler gas tank first. We're going to be making a chopper style gas tank from steel. So when you embark on any metalworking project, you need to know what size and shape the parts are that you'll be making. Let's take this aluminum gas tank off and we'll start the patterning process for the steel tank. My favorite material for making patterns from is called chipboard. It's a heavy paper. I like it because it has more flexibility than corrugated cardboard, yet it's stiff enough to hold its shape. Something like butcher paper doesn't hold its shape very well. So we have a small piece of this material ready to go. We're going to clamp this into place on the frame of the motorcycle. And I'm going to position the bottom edge of this chipboard just about where I want the bottom edge of the tank to go. And what we'll do now is to sketch in the profile of the tank, the front edge, the top surface, and the rear edge. And we could do this sketching in a number of ways. We could do it with pencil, we could do it with pen. I'm going to use masking tape. One of the things I like about masking tape is it's very easy to describe a straight line. And I'll put the tape on where I want the front edge of the tank to be. The top front corner of the tank I want to have a constant radius, so I'll actually use the roll of masking tape as a template to create a constant radius curve. And now we'll use the masking tape to make that line much more visible. And the next thing we'll do is to describe the top surface of the tank. Now I don't want this to be dead flat. I want it to have a nice flowing curve going back toward the rear. And you can see how wonderful this masking tape is for developing a smooth, even curve. And in the rear, I'll have to take this clamp off temporarily to position the tape where I want it to go. Okay, let's clamp it back up. And I need to take a look at this to make sure that the shape is what I want. I think I like that shape pretty well. If there was anything I didn't like, this would be the time to make a change. The nice thing about masking tape is you can lift it up and reposition it. We could make this angle steeper or more blunt, but I think I like it just about where I had it initially. And what we'll do next is we'll take this off and trim this first template on the outside of the tape. I like using tin snips for cutting the chipboard. You certainly can cut it with scissors, but there's something about the size and heft of the tin snips that I like a lot. Okay, we're cutting around that rear corner now. And we'll clamp this back into position on the motorcycle frame and take a look at the results. So there are many ways to position a gas tank. Some of the things I'm looking at are we need clearance at the fork so that when the fork is turned to its limits, it doesn't bump the tank. I'm making this tank so that the bottom edge of the tank just touches the top edge of this element of the chassis. And I want the rear edge of the tank to be flush with the bottom of the top frame rail in the rear. And I just want to be sure that I like this shape pretty well before we go on to the next step. And I do like it. So what we'll do next is we're actually going to make a buck or a set of connected templates to use as a target for shaping our metal pieces against. The material we're going to make our buck from is called MDF, or medium density fiberboard. It's a material much like particle board, but I prefer it because the MDF can be sanded to be a smoother surface. Also, it doesn't dull your cutting tools as quickly as particle board does. So the buck will be comprised of two main elements, the base, which I'm holding, and you'll see I've marked a center line on the base, and then there's a part that goes perpendicular to that I'm going to call the backbone of the buck. So the pattern that we made that shows the profile of the tank will be transferred onto this backbone. Now you'll notice that the base plate spaces the backbone up one material thickness. This is 1/2 inch thick MDF that we're using. So as we do the layout, I want to drop my pattern down one material thickness so that when the backbone is put on the base plate, the total height of the tank will be the same as the total height of the buck. So I'm going to align my pattern on the piece of MDF. I'll use a pencil to trace a line around the edge. And now we're ready to trim our part on this line. Now we could trim this a number of ways. We could use a saber saw. I'm going to use a bandsaw because it's a little more convenient. So I'll put a face shield on, start the saw, Okay, we now have the backbone cut for our buck. I'm going to position that on the base plate. And now the next thing I'm going to do is to think about the perimeter of the base. That has not been defined yet, and that's the very next step in making the buck. So I'm going to line up the back part of the backbone, the back edge of the backbone, against the back edge of the base plate, and make a mark that represents the front edge of the backbone. Now we're going to design the curve that will define the top view of the tank. And again, there are many ways we can do this. A very wonderful layout tool that I often use is welding rod. This is 3/32 aluminum welding rod. And if I'm careful when I bend it, I can cause this rod to take on a very uniform contour. So by bending this rod a little bit at a time, I'm going to start looking for a shape that I find pleasing. Our tank will not have totally flat sides, so the side of the tank needs a little bit of curvature. And I want the tank to taper quite a bit toward the rear. It's going to be rather broad in front and rather narrow in the rear. Okay, I'm fairly happy with the contour we have established on the front portion. I'm going to pencil that in on the MDF. And the curve on the rear is tighter than I can easily make with the welding rod, so I'm just going to sketch in a curvature that looks about right to my eye. So I've defined 1/2 of the curve, and I'm going to cut this out first, make a chipboard pattern of this curvature, then flip that pattern over to ensure that my base plate is made absolutely symmetrical. So let's trim this now on the bandsaw. Okay, I've trimmed one side of the base plate, and the next thing that I will do is to put a piece of chipboard right on the base plate so that the edge of the chipboard is on the center line of my base plate. Flip this over. Mark my chipboard with a pencil. Next, I'll trim this on the pencil line. Then I can flip this pattern over, remark the base plate on the other side, and I'll be sure that I have a symmetrical base plate. So the base plate has been trimmed to be symmetrical, and I've done a couple other things as well. You can see I've drilled some holes through the base plate. These holes will be used to accept the tips of clamps that we'll use to hold sheet metal tight against it. Also, I've marked the areas where the stations of the buck will go, the partitions that show the contours for the side of our tank. So the next step is for us to glue the backbone onto the base plate. And I'm going to use hot glue for this. Hot glue is not a particularly strong glue, but it's very fast and very easy to use, and it'll suit our purposes nicely. So we'll put a nice bead of glue right down the center of the bottom of the base plate. And while the glue is still hot, we'll nestle it into place, right into the marks we put into place. And next we'll start looking at how the stations of the buck will be fitted into place. This is a blank we have that's slightly oversized. Notice the corner has been beveled slightly. This is so it will skip over the bead that the glue has left. And I want to make a mark on this that's absolutely vertical. So I put a carpenter's square in a drill press vise to hold it vertical. We'll use that to draw a nice vertical line. And we're going to make a mark on the top of this station that shows where the top portion of the backbone meets it. And we'll draw a line there as well. So now we have two lines that show the boundaries of what this station will be. What's next is I want to arc this top line. I don't want the top of our tank to be totally flat. So I'm going to use a piece of welding rod. I'm going to bend the rod until it has an arc that I like. I'm going to rest that rod into place on the station. and draw an arc. And the last step is I want a radius that connects this arc to the flat side. And I'm going to use a little cutoff wheel that has a diameter that matches what I want. Use that as a template for drawing the curved line. So we now have the lines drawn that define the perimeter of this first station. We'll cut this out on the saw and then use this piece as a pattern for cutting the matching piece that goes on the other side of the buck. The other stations will be all made in a similar manner. So here's the buck with all the stations glued in place. You can see that I've gone back to sand each of the intersections where the stations meet the backbone of the buck. There's an angle that's been established for each station that matches the angle of the backbone. On the front, you'll see that the base has been sanded to match the angle of the backbone. And also notice that I've put marks on each of the stations showing where the division will be between the side pieces and the top piece. We're looking at basically a three-piece construction for this tank. Left side, a right side, and a top. So the next step is to make a pattern for the piece of metal that will fit against the side of the buck. I'm going to tip this up on its side, and we'll be using chipboard again. So we'll lay the chipboard loosely on the buck with a little overhang on the bottom side, and we'll start holding the pattern paper to the buck using push pins. One of the advantages of working with MDF is that push pins go into it easily. When we're at the front, I want to make sure that the radius at the top of the tank is the same as the radius at the base, and we can adjust that by how we lay the paper onto the buck. Okay, so I'll flip this around, and now we can use a pencil to mark where the pattern paper meets the base plate of the buck. We'll make a mark all the way around. And now we'll flip this right side up. And the next step is to make a mark at each of the points where the pattern paper can be folded down to touch the mark we put on each of the stations of the buck. Next step is we'll take the pattern paper off the buck, draw a line that connects the dots that we've made, and trim the pattern on this line and on the bottom line. Our goal is to create a smooth line that connects all of these marks we made on our pattern from where they intersected the stations of the buck. One way to do that is to bend a piece of welding rod to make a curve that will evenly connect all those points. So this is 3 32nd-inch diameter aluminum welding rod. It has just enough body to hold its shape as you mark it with a pencil. Okay, I think we're getting pretty close. I'll put a weight on this end of the welding rod to hold it in position. Hold the other end with my finger. And now we can draw our line. So now we're ready to trim our pattern. And there's the completed pattern for the side of the gas tank. To make the pattern for the top of the buck, we'll flip the buck upside down, put it on the paper, start with a single push pin in the back. Then we'll work toward the front, pull up the slack in the pattern paper so it's a nice snug fit against the backbone of the buck all the way up to the front. And now we'll mark the intersections of the pattern paper with the marks on the stations of the buck. So I've drawn a line that connects all of the marks we've made on the pattern paper, and now we're ready to trim it out. I've held the patterns to the buck with push pins, and now we can check the alignment of the pieces. And you can see that if you press each pattern piece down tight against the buck, the edges just about meet, or meet with a tiny bit of overlap. So I'm pretty happy with the sizing of the pattern pieces. I trimmed just a little bit off the rear of this pattern to get a good fit between the top pattern and the side pattern. And I think what's next is we'll lay each pattern on a piece of metal, mark around the edge, and then we'll trim the pieces out. We're ready to cut out the side piece for our gas tank now. The material that we're using is 18 gauge aluminum keeled steel. This is about 45 of an inch thick. I wouldn't recommend using anything thinner for a motorcycle gas tank. The aluminum keeled steel is somewhat difficult to find. The advantage is it's softer and easier to form. You can do the same thing we'll be doing today with regular cold rolled steel. It just takes a few more hammer blows to do the forming. So we'll lay our pattern on top of the metal. I'll be using a felt tip marker to make a line around the edge. And this pattern was made to be a pretty accurate fit on the buck. I really would like to have a little extra material during the forming stage. So after I've marked the top edge of this, I'm going to slide the pattern toward me 1/4 of an inch. That means the piece I'll be forming is a 1/4 inch oversize. You'll see in a few moments why that will be an advantage. And now we're ready to cut our piece out. So I'm going to demonstrate several different techniques for cutting steel sheet metal. The tool that I have that's probably most commonly found in people's home shops that will do the job is a saber saw with a metal cutting blade. So I'm going to clamp this to the table with C-clamps so it doesn't bounce around as we're cutting. I'll be using a face shield and hearing protection. And I'm using a jigsaw that has a very fine-toothed blade on it. So there's our first cut with the saber saw. You can cut a fairly accurate line using the saw. It leaves a little bit fuzzy edge. There are burrs of metal left on the edge. We'll have to dress that with a file. But it's a reasonable way to cut this material. A tool that's quite a bit faster that does the same job is an electric shear, and let's demonstrate that next. So the electric shear is quite a bit faster and it leaves a clean cut. The disadvantage is I cannot cut accurately with the electric shear. So what I do is I cut oversize about 1/4 of an inch with the electric shear and then come back for the finish cut with hand shears. The reason we didn't do the initial cut with aircraft shears is because these only work well for cutting off a thin ribbon of metal. It's very difficult to cut off a strip of metal 2 or 3 inches wide or more using only the hand shears. So I will finish this cut later. I want to demonstrate what's become my favorite technique for trimming panels. It's a tool called a Beverly shear. As you can see, it's quite rapid and it leaves a pretty nice edge. You can cut very accurately against a line using this tool. So that's how the pieces are trimmed to size. Now we're going to contour our side pieces to match the buck. The low crown contour across the side I can accomplish just by bending the metal in my hands. We'll test that fit. I think it needs just a little bit more. That's matching pretty well. For this higher crown contour in the front, I've made up a very simple fixture. I've clamped a piece of scrap steel bar to my table, but there are 1/8 inch thick spacers that raise it off the tabletop 1/8 inch. That provides an opening, allowing me to slip the metal into the opening, and then I can pull the metal up to put a bend in it. And we'll do this in several stages. I'll bend it just a little bit, go back to the buck, see how the form is coming. Needs quite a bit more radius, so we'll go back into the fixture, bend it a little bit more, just in that one area. Test it on the buck again. And we're actually fitting pretty well. Maybe just a little bit more in the front. I'll spin this around so you can see it. We're just about perfectly dialed in. So let's do some curving on the rear now. Okay, that's a good start, and I'm going to complete this using hand tools. So now that the side piece is rough formed, the next step is to curl over the top edges. Where the metal is straight, we can curl it over by only bending the metal. But where the metal makes a curve, we need to shrink the metal to allow it to fold over. So I'm going to be using a mechanical shrinking machine to help me with this operation. So the metal is placed between the jaws of the machine. The handle is pressed down, and each time I press it, the metal between the jaws is compressed or shrunk. And you'll see shortly that that does a nice job of causing the metal to fold over. Okay, there's our first couple of passes, and I think you can see that we've tipped the metal over to about a 15-degree angle. Let's try this on the buck now, just to test how far we've come. And it's certainly headed in the right direction, but we need to go quite a bit further. So we'll go back to the shrinker and repeat this a few more times. In the end, we'll have to fold this flange over to about a 45-degree angle. Okay, we're up to about 30 degrees now. Try it back on the buck. It's coming along nicely. We just need more of the same. Back into the machine one more time. Okay, we're at just about 45 degrees now. We'll try it on the buck, and it's close to fitting right. Now, what I've done is just pull the edge down. I'm not dealing yet with shaping the metal adjacent to the edge. That will be done in the next step. But it's easiest to shrink the metal first with the machine and then come back with hand tools to blend the contour into the proper shape. What we'll do next is to use a post dolly, which we have mounted in the vise here, to smooth the transition between the part that we've formed over with the shrinker and the broad face of the gas tank side. Also, we're going to use the same post dolly to round over the metal which hasn't been moved yet. So I'll be using hearing protection for this. And I'll be using a lightweight hammer with a low crown face. We're going to position the metal on the post dolly so it overhangs just a small amount and tap it down over the edge of the post dolly. So I've contoured a strip of metal about a ½ inch wide. I'm going to go back to the post dolly and hang it over the edge a little bit more and come back now for a second pass. And now we'll try this on the buck. And what I'm looking at is how this radius I've just formed relates to the contours of the station of the buck. And actually, we're pretty darn close. One thing that happens as you curl metal over like this, we had a soft curve on the side of the tank to start with. Making this curled over edge has straightened out the part. So the next thing I'm going to do is to use the shrinker to shrink this edge a little bit, and that will help to pull the contour back into the panel. So let's go to the shrinker, and we'll just hit it a couple of times fairly lightly on this edge. I think you can see that's just pulled a little bit of contour into the part. Let's try it on the buck. It's fitting much better now. And in fact, the contour I have between these three stations is just about perfect. So my focus next will be on the front portion of this part. And what we're trying to do is to soften the transition between this area that really was kind of flattened by the shrinker and the face of the gas tank. So we'll position this right over the crest of the post dolly and start hammering down against the dolly. Okay, we'll try this on the buck again. Get the bottom edge aligned. Check my fit against the stations of the buck. Actually gone just a tiny bit too far with the front, so we'll flatten that out a little bit. Back to the buck. So the front looks quite good. In general, it looks good, but I'm going to work a little more on the transition between the curved front edge and the broader radius side. Try that on the buck again. And each time I put the part on the buck, I'm being careful to align this edge of the part against the far side of the backbone. Remember, that's how we made the pattern. So it's overhanging the center of the buck by 1/4 of an inch. Okay, so I'm pretty happy now with the fit of the front of this and the side of it. I'll do a little work on the rear of it now. Off camera, I had done some shrinking on this corner to help pull it down, and now we'll work over the post dolly to put a little more radius in that. Try that on the buck again. Just a little tightening up of the radius right here is what's next. Back to the buck. And by gosh, that's a pretty darn good fit. So we have both side pieces clamped onto the buck now. And you can see that they're both fitting the buck pretty nicely. And what's next is we're going to start shaping the metal that fits on the top of the buck. So this is the material we've cut from our pattern. The first step is I'm going to just bend this with my hands to give it a slight amount of contour so it matches the contour of the buck. Okay, and I'll give the bottom of it a little bit of a curl as well. And from this point, the rest of our shaping will be done working with a mallet into a sandbag. So I'll put my ear protection on again. We'll put the metal on the sandbag and we'll start tapping it. Now the pattern I use will start in the center and then we'll kind of spiral out from that. I'll let you see the top side of this now. It's pretty bumpy, but we're going to just rough it out first with the mallet and bag, and then we'll smooth it later on. Just the rough shape we want. So the contour I have right to left is pretty good, but what's wrong with this is we don't have enough contour front to back. So to pull that contour into it, I'm going to start using the metal shrinker on both edges. And you'll see that that will start to develop the curvature we need from front to back. So let's go over to the shrinker. And we'll just gently start pulling these edges down with the shrinker. Okay. Now we'll go back to the buck and see how the shrinking has affected the shape. And I think you can see that it really has helped to establish the curvature from front to rear. So from this point to this point, our fit is pretty decent. There's a huge gap in the front, and what that tells me is I need to do a lot more shrinking on the front edge of this to help pull it down. Actually, I can do a little bit of that work by bending. But it still does need more shrinking in the front to help close this gap. So we'll go back to the shrinker. Focus mostly on the front edge. Okay, we'll test this again on the buck. Much better fit this time. So we've now established the all-over shape of this part. It's not ready to weld together, it's not ready for paint, it's still a very bumpy, textured surface, but the all-over shape has been established. And the next steps will focus on smoothing this out. The first technique we'll use is to use a mallet working against a heavy steel plate. This is a piece of 1/2-inch thick steel plate I just put on my table. I sometimes use wood as a backing, but we're going to use metal today. I'll put my hearing protection on. And using a mallet, we'll just strike the metal against that hard metal surface, and it will help to smooth the entire surface. Okay, I think we've gone far enough with that. So the first work with the mallet and sandbag, I think, made the part look something like a bag full of oranges. And now I think it looks something like a bag full of walnuts. So we're definitely making some progress. For the next step, I'm going to put my sandbag on the edge of the table. Now I'm going to put a dolly on the sandbag. The sandbag simply is acting as a support for the dolly. And I'll be working with a slap hammer, just compressing the metal against the dolly. Okay, I think that's as far as I'll go with this technique. You can see from this point down, the metal really has smoothed out quite a lot. So what we're doing really is just compressing the metal between the slap hammer and the dolly. And if you just keep hammering, pretty soon the metal takes on whatever contour the dolly has. I call this the anvil technique, and it's actually one of the easier metalworking techniques to master. When we started, the metal has lots of little hills and valleys. If you strike on a hilltop, then there's an air gap under the metal as you hammer it. The more you hammer, the thinner that air gap becomes. So it moves the high spots down. If the spot that you're hammering is a valley, then the metal is touching the dolly. When you strike the metal with the slap hammer, you're stretching the metal, which will make it rise. So all of your hammering will either lower high spots or raise low spots, and that's what makes the metal smooth. For the next stage, we'll be using a benchtop English wheel to do the smoothing of this panel. Now, everyone seems to think that the English wheel is a magic machine. Actually, it does the same job as a hammer and dolly. It's simply a little bit faster and quieter than a hammer and dolly. The lower wheel is called the anvil wheel, and they're interchangeable. Here is a wheel that has a high crown. The one that's in the machine now has an 8.5-inch radius. The general idea is that you choose an anvil wheel that has a curvature that pretty closely matches the panel that you're working on. So this 8.5-inch radius wheel is just about perfect for the panel we're working on. So you need to set the position of the lower wheel to create pressure. On this machine, what I normally do is bring the wheels together so they just touch, and then turn the crank about 3/4 of a turn past that. so it generates nice steady pressure on the metal. Then to introduce the metal between the wheels, it's very helpful to spin the top wheel just to get the metal between the wheels. And then we start rolling the metal between the wheels from one end to the other. So the pattern I'm using is very, very basic. It's just like mowing a lawn. You make a pass across the metal, then you start steering the metal. I'm steering from my left to my right. And as the metal traverses through the machine, it just starts flattening out all the hills and valleys. The high spots are moved down and the low spots are moved up. But it's considerably faster than a hammer and dolly. And usually the results you get are superior when using the English wheel. So there's our first pass, and it's not ready for paint yet, but obviously it's much smoother at this point than it was when we started. So we've covered an area over a foot long and about 6 inches wide, and a fraction of the time it took us to smooth this front portion using the hammer and dolly. So let's go back into the wheel again. We'll make another series of passes across the panel. The tail end of this panel, the piece that's in my right hand, I'm going to put off shaping that until the last. I'm going to focus on getting the all-over shape in the panel correct first, and then we'll reshape the rear end as it needs reshaping once we start really fine-tuning the fit against the side pieces. Now I'm changing my angle of attack to go along the length of the panel. And the space between my tracks is about 1/4 of an inch. The more you use this machine, the more control you gain over the accuracy of the spacing of your passes. And ideally, you'd like to have them really quite parallel. Saying that another way, you want the spaces between your passes to be pretty consistent from one spot to the next. Okay, so it's much smoother at this point. And I'm going to lighten the pressure a little bit, about 1/4 of a turn from where it was. And now we'll lightly track over the entire surface. And this will help smooth it even further. Turn the panel around. Now we'll work on the nose of this a little bit. That's the part we smoothed with the hammer and dolly. But actually the English wheel will get it even smoother yet. Okay, so that's just about as smooth as it's going to get. And what's next is we'll check the fit of this on the buck along with the side pieces. Okay, I think our fit actually is quite nice. I still haven't addressed the tail of this piece. We'll do that pretty soon. I'm just looking at the contour across the top. And I think the shaping of the middle of this panel really is what we want. We'll do the fitting on the tail end of this piece now. We'll put it onto the buck, position the front edge approximately where it goes, and I'm going to mark the area where this needs to start curling down. Now we need to do two things in this area. We need to both shrink it and bend it. And I'm going to do the shrinking first because once it's bent, it's difficult to get this material between the jaws of the shrinking machine. So I've marked the areas to be shrunk, put those areas in the jaws, and give it a couple of good hits on both sides. Try this on the buck. So it's definitely headed the right direction. And I'm just going to bend this a little bit by hand to encourage it to take on the contour required by the buck. So that's a pretty decent fit. The majority of this surface matches the buck quite well. The next step is to curl the edge of this over so it matches the buck a little more closely. The center is fitting well, the edge needs more curl. On the side pieces, I used a slap hammer and a post dolly to do the curling. We're going to use a different tool to curl these edges, and it's called a beading machine, and I have a special set of dies put into the machine. These are dies I've made myself, and they're designed for rolling over edges. If you're just making one tank, it's probably not worthwhile to make a set of dies like this. But if you're doing a number of tanks, this can really be a time saver. Let's see how it works. So I've set the gap between these dies, the same as the material thickness, and we'll just introduce the metal between the dies and start rolling it through. And it puts a very nice rounded edge on the metal. Same thing the hammer and post dolly does, but faster and smoother. We'll continue fitting the part to the buck. The area that was worked with the shrinker has lots of flat spots in it, so we're going to start working over this post dolly again to help smooth these out. By the way, the post dolly is available from Fournier Enterprises in Troy, Michigan. These are very, very handy tools. So I'll put my hearing protection on. And we'll try it back on the buck again. Needs just a little more curl on the end, which I can achieve by working over the post dolly. Try it on the buck again. And I'm pretty happy with the way it's fitting. Bend this down just a bit more with my thumbs. Yeah, we have a very nice transition now between the side pieces and the center part. So we placed all three pieces on the buck. The top I've actually held into place with a couple of wood screws. We could certainly put holes wherever we want and then fill the holes for the screws later on. But I've planned ahead. We're going to put a cap on the top of this tank, so I put the screw right where the cap will go. And in the rear, I put the screw where the tunnel will be cut out later, where it fits over the top tube of the frame. So the fit on the buck is pretty decent at this point. And we're going to start marking the pieces together and trimming them to fit. The very first trimming cut to be made will be made right on the front. So I've already cut this half of the tank right on the center line. Remember when we started, it overhung the center 1/4 inch. So I marked center, trimmed that, and now we'll use this part to scribe against so we know where to trim the second part. So we have both side pieces clamped onto the buck, and now we're going to tack weld them together down this central seam. Okay, our tack welding is complete. You can see that when I'm tack welding on top of the buck, it actually heats up the buck to the point where the material chars and gives off some smoke. We would not want to weld the finished seam on the buck, but tack welding seems to be okay. We're ready to scribe around the edge of the top now in preparation for trimming. So I'm going to make one firm scribed line. We don't want to go back and forth and make a bunch of small lines because then you don't know which line to trim on. Coming back to do the left side now. Okay, our line is scribed. Now we'll pull the top off. We'll release the buck. And now we're ready to trim on our scribed line. So we've trimmed the parts and reassembled them on the buck, and now we're ready to tack weld them together. Since I'm going to be using my left hand to align the parts, I need to fit the pieces so we have metal-to-metal contact, so I can make a fusion tack weld. That is a tack weld that's made without any filler rod at all. My control of the alignment is done with a putty knife. So if I can place a putty knife into the gap between the pieces, then I can manipulate the metal back and forth until I do have metal-to-metal contact. So let's go ahead and make a tack weld right at this spot. I'll put my hood on. And here we go. So there's our first tack weld. Now that we have the metal positioned with the tack, we can do a little bit of tapping on it to get alignment at some of the other spots. Okay, we have good alignment in this section of the joint. So now I can use filler rod to make a little more substantial tack weld. And now we can start working this welded joint down toward the other end. We've completed the tack welds, and they're spaced no more than 3/4 of an inch apart. What's next, before we make the finish weld, is I want to do some hammer and dolly work on the joint to make sure we have proper alignment between the parts. What I don't want is to have one part of the joint higher or lower than the other. So we'll work this entire seam to smooth it out. We're ready to do the finish welding on this part now. Now I've been using the TIG welding process, TIG, and that's my favorite process for a number of reasons. It gives me control of the heat during the weld. I have a foot pedal I can use to increase the heat or decrease it, and it gives only a small amount of distortion, and it leaves a very workable weld. But a tank like this could be welded with any process. It could be oxyacetylene welded, it could be MIG welded. These would all be excellent ways to join together motorcycle gas tanks. So let's get on with the process. So that's the nature of the TIG welding process. It leaves a rather small bead, and the bead is soft enough that we can actually hammer and dolly work it. The weld is complete, and before I do any hammering on this area, I'm going to sand the weld so that it's flush with the metal next to it. I'm just sanding off any part that sticks up above the base metal. With the weld sanded smooth, we're ready to do the final smoothing of this part. So I've clamped the tank to my table, and I'm using a dolly on the inside that has a shape that I like. I'll put on my hearing protection, and we'll start smoothing the transition between the side piece and the top piece. Okay, I'll test this with my hand. And it's feeling very nice to me. What I'm looking for here is a nice transition between these shapes, something that doesn't have any peaks or valleys in it. So this section is fairly well finished. Now we need to reclamp this to do the front portion and the opposite side. Okay, so I've done a little more hammer and dolly work on these welds, and I've done just a little bit of sanding to smooth the metal and get rid of the last traces of the weld bead. And I've just gone over the whole weld area with a strip and clean disc that gives it a nice uniform finish. Now I know this looks very smooth on video. It's actually not quite ready to be painted yet. There are just a few little undulations in the metal that can probably be best dealt with filler or doing some heavy block sanding on primer. I've also trimmed the bottom edge of this tank to make it uniform, and I've decided to relocate the cap slightly. My original intention was to have the cap centered on the screw hole that we used to hold the tank to the buck. And I decided to move it forward about a ½ inch just so the cap is a little more centered around the front portion of the tank. And I'll spin this around now so you can have a nice close look at the inside so you can see where the weld's been pretty well flattened out by the hammer and dolly work that we did. And you can see the inside of the tank looks really quite nice and uniform. And what's next is we're going to put this back on the buck simply to offer it support. And I'm going to use a hole saw to make the opening for the bung for the gas cap. So we'll be using a hole saw that's centered in a 1/4 inch hole. I'm going to use a pneumatic drill to actually spin the hole saw. We'll put a little bit of cutting oil on the saw and on the metal. And I'll get my earmuffs for this. Give it another dab of cutting oil. A little more oil. And there's our hole for the cap. I'll be using a bung that I cut out of an existing gas tank, and that fits neatly into the hole. We're going to weld the bung into the tank now. I'm going to be using silicon bronze filler rod. The advantage of silicon bronze is that it causes less distortion than mild steel. We certainly could do this job with mild steel as well. So we'll put tack welds spaced evenly. And I'm going to tap the bung down just a bit. To make sure it's seated tightly against the tank. And now we're ready to do the finish welding. And there's the bung with the welding completed. The next thing we'll do is to make the tunnel for the tank, and there's many different approaches that can be taken for this. Certainly the tunnel and the bottom of the tank can all be made from a single piece of metal on a flat bottom tank like this. There's a lot of difficulties in making it from a single piece, however, so the approach I'm taking will make the part in two pieces. But the weld will go down the center of the tunnel, and this has some advantages, such as putting the weld in a place where it's not seen, and it puts the weld in a place where it will cause a small amount of distortion because of the curvature of the top of the tunnel. So I've made a very simple bending fixture. There's a piece of 2-inch diameter steel tubing I've clamped to my table. We're using the 18 gauge aluminum keeled steel as the material to be bent, and I put a couple of marks on my sheet of metal showing me where the bend is going to start. So I'll align the marks with the edge of my table, clamp everything together, and then to make the bend, all I need to do is to roll the metal up over the top of the tube. And I'm going to go a little bit past 90 degrees. That should be fine. Now we'll release the tubing, pull the metal out. So there's our bend, and what's next is we're going to trim this panel right in the center. The part we're keeping is the part on my right. We're going to make a cut on this right down the center of the tunnel. So I need to make a mark that's spaced 1 inch away from this face of the material. Very easy way to do that is with a height gauge. This tool will leave a very fine line, which is excellent for trimming on. So there's our line, and the next thing we'll do is to make a cut on this line. So we form both halves and trim them, and they'll fit together in this manner to create the tunnel. The next step is to lay out the bend that we put on each half. So I'm just going to place this on the table. The way that we know where the bend goes is going back to our original pattern that we made for the part. This shows the top part of the tunnel where it goes through the tank. So we'll align this mark with the edge of the bend, and then I'll use the bottom of the pattern to trace a line onto our blank showing where the bend will go. So we'll put the bend in each part now. We have the bending brake set up. I'll align my bend line with the top jaw of the brake. Clamp it in position, and we'll make a 90-degree bend. There's our first part. Now we'll make a similar bend in the second part. So now that both sides are bent, we're ready to weld them together. I'll set them down on the table. And we'll start tack welding from the rear of the tank. So we've cut out an opening in the tank in the front and rear for the tunnel. And the next step is we'll place the tank over the base and tunnel. I'm going to use a sandbag to weight the tank to hold it tightly against the base. And now we'll scribe on the tunnel and the base to mark where it's going to be trimmed. Okay. Now we'll pull the tank off, and now we're ready to cut the base on the scribed line. So the base plate is trimmed to size, and the next step, of course, is to put the tank on the base plate to get them properly aligned, and then we'll first tack weld them together and then do the finish welding. Now, I'm being very careful at this stage in noticing how the pieces of metal fit, and let me show you what I'm talking about. The type of fit I want between the pieces of metal is either a corner-to-corner fit like this, or what you might call a half lap, where the material being welded to the other piece laps over 1/2 the material thickness. And this is crucial. It's easier to fit things together edge to edge so that your weld would go down this surface, but the problem is it's very difficult to get full penetration with a fit like this. If you make a weld that has less than full penetration and then sand that weld flat, you have a joint that's very liable to break under vibration. So again, we want either a corner-to-corner fit on the edges of the piece of metal or a half lap fit. Then you can safely sand the weld until it's flush and be assured of having a strong joint. So here's the gas tank, completely welded and sanded smooth. You can see that it has a nice flow of contours, and it should make a very nice addition to a chopper-style motorcycle. This is the end of part 1. In part 2, we'll show you how to mount a tank. We'll also show you how to make a more curvaceous tank working with aluminum and how to test your tank for leaks.